Hi everyone. So today I am going to talk to you all about this molecule, NAD. Now it's something that's already been said quite a few times. Lots of people have mentioned it already. But what actually is it? So NAD is a natural molecule. It is found in every single cell in your body. It's involved in over 500 different reactions. And if you didn't have NAD in your cells, you'd literally be dead in 30 seconds. So it's a very, very important molecule when it comes to biology. But perhaps most specifically to this conference, it's been very closely associated with aging. So what has it got to do with aging? Well, the problem is that our NAD levels actually decrease exponentially as we get older. So when you're young, you've actually got really high levels of NAD, but by the time you get into these sort of ages down here, you've actually really got very little NAD left in your cells. And it's actually this decrease in NAD that has been found to correlate with the onset of the symptoms of aging. Now, to understand why NAD is linked to the onset of aging, you need to look at what it's actually doing in the cell. So high NAD actually acts as a signal to basically switch on all our maintenance and repair processes in our cell. So when you're young and you've got high levels of NAD, what you find is you get healthy mitochondria function, you get activation of your longevity genes, you get decreased inflammation, increased DNA repair, all the things that your cells need to stay in good health. So when you get older and your NAD levels actually start to decline, basically all of these functions are getting turned down. And it's that problem that causes damage in the cells, and damage in cells is linked to aging. So what actually causes our NAD levels to decline? Because everyone says, well, if it's so important, then why is it going down? Why is this happening in our cells as we age? And to understand this, first you need to have a good understanding of how NAD is actually made in your cells when they're young. So just imagine that this big square is a cell. It's a very simple version of a cell. The first thing I want you to notice is how big this NAD molecule is. It's not small. And this presents the first problem with NAD, is that it really struggles to cross over cell membranes intact. In fact, the majority of cells, it simply can't diffuse through. So this means that NAD actually has to be made within the cell, where it's actually